12,000 years ago, the dire wolf roamed the earth. Towering over the modern grey wolf, it was a fierce predator, stronger, heavier, and more suited for survival in a much colder, harsher world. Then, like many species of its time, it disappeared, extinct, lost to history. But today, that history is being rewritten. Scientists at Colossal Biosciences have recently done something extraordinary. They've taken the first real step toward bringing the dire wolf back to life, reversing extinction through a process known as de-extinction. It all began with something ancient, over 13,000 years old, a tooth and a piece of skull preserved for millennia. From this fossil, scientists extracted precious fragments of DNA. Although the DNA was degraded and incomplete, it still held clues that helped reconstruct the blueprint of this long-lost predator. To make sense of that DNA, the team compared it to the dire wolf's closest living relative, the grey wolf. Through deep genetic analysis, they identified 20 key differences. The dire wolf was significantly larger, had a broader skull, and sported a thicker coat built for Ice Age climates. These differences weren't just cosmetic, they were part of what made the dire wolf a unique species. Now, knowing these differences wasn't enough. The team needed a way to bring them to life. To do that, they turned to endothelial progenitor cells, EPCS, cells found in the blood vessels of living grey wolves. These cells were chosen for three important reasons. First, they can be extracted without harming the animal. Second, they respond exceptionally well to gene editing techniques. And third, they can be easily replicated in a lab setting. Using a powerful genetic tool called CRISPR, essentially a molecular scissor, scientists began editing these EPCs. One by one, they introduced the 20 key traits of the dire wolf into the grey wolf cells. Bit by bit, those modern cells began to look, genetically speaking, more and more like their ancient ancestors. But editing the genes was just the beginning. The next challenge, creating life. The nucleus of each edited EPC cell, where the DNA is stored, was carefully removed and transferred into a donor egg cell whose own nucleus had been taken out. This created a completely new embryo, carrying the edited, dire wolf-like DNA. The team successfully created 45 such embryos, nurturing each one to reach the stage suitable for implantation. And now came the final step. Those embryos were implanted into the wombs of two healthy ehound dogs, selected for their ability to carry large pups. These dogs would act as surrogates, not just carrying the embryos, but bringing to life an animal no one had seen for 12,000 years. After 65 days when those pups were born, history was made.